Still morning, so good morning. Morning. This is right after the coffee break, isn't it? Could do a bit better. Good morning. Morning, awesome. Quite excited to be here. Thank you everyone for making time this day today. We are delighted to have you here and share in this next session about our learnings from what we've seen our biggest, largest, complex customers do in their journey with cloud transformation. As I was sitting there and listening to what Howie just presented, there are a couple of things that I think nicely flow into what we're going to talk about. This important tenet of the Services 4.0 vision that Howie shared with us, one of them was being cloud native, right? And the facts that he mentioned around the best banks, in this case TBS, being able to release software much more faster than any of their competitor is an important element in they being more successful than their competitor, right? Because I think everyone here is in the software industry, and you know that today, be it a competitive threat or be it an opportunity, be it a new revenue model, the default way for a company to respond is through software, right? Gone are the days of I'm going to set up 10 more buildings and have a lot more real estate and 2-year business expansion plans. Software allows you to react so much more faster if your software is set up to react much more faster, right? So we're going to talk a little bit about what some of our topmost clients are doing. Customer success for us here at Pivotal is a very integral part of what we do. It's who we are as a company. Is focusing a lot on the success of the business. What is the business trying to do that technology can help with? Because I think, as all of you know, technology on its own provides no advantage. Installing 10 more tools give you no advantage if they don't translate to a business outcome. Excuse me. So here's a great example. I mean, everyone knows T-Mobile, one of the largest carriers in the US. And I'm going to share a couple of more examples that are more in our region. This one is just so good because of the amount of impact, software has been able to drive for them. You can read at the numbers, being able to run 34,000 plus containers from, and this is data from many months ago, it's gone up to 50,000 and more recently. Being able to run that scale of applications in a cloud native format, being able to deliver daily transaction workload of over 300 million, being able to improve the stability of the software as measured by 83% improvement, a reduction in the level of incidents. This is a great example of what T-Mobile in this case is able to achieve by going cloud native. By building software that's more resilient, by building software on top of platforms that offer you scale and stability, this is an awesome foundation for the business leaders of T-Mobile to say, I'm confident I can respond to an external opportunity or competition much more faster versus if I did not have such a capability in place, right? So that's big confidence building for business coming from IT saying, I can trust. I've got to roll out new initiatives. This is proof point of IT is no longer the blocker. Software is no longer the blocker. Software is now the enabler. So impressive results, but if you double click, one more level, they get even more impressive if that was possible, right? What you see here is the outcome of a typical study called value stream mapping. A lot of the people in DevOps and software would know this. Value stream mapping is a very popular methodology to analyze the waste in your life cycle, right? So we do this study with all of our largest clients that we work with, and this is the representation of the outcome of their work, as an improvement before they worked with us, and the result thereafter. And you can read the numbers. It's very, very impressive. And this is not the only one. The folks that know Pivotal know that we work with the largest, most complex customers around the world, and these businesses by nature are very difficult to transform, right? It's easy for a software company or a business setup today that's born in the cloud native area to transform quickly, but for a giant like this that's embedded in years of legacy software, years of processes to be able to transform and produce results like this is awesome. And then you come closer to home, right? Our favorite bank here in the region, and how we alluded to that. A lot of accolades, a lot of awards, and I know there's a bunch of DBS people here in the room. Congratulations for all the great work you guys are doing. again, an impressive set of results, in terms of what they've been able to achieve. And as you peel back, you look at all the external good work that's happening, whether you're a DBS client or you're in the industry, you look at everything they're achieving, you peel it back, it comes down to basics like these. Being able to do much more responsiveness with software while not compromising anything else. You saw the previous slide with T-Mobile. It's not as if they got a lot more stability by compromising speed. Because in our industry, it's an easy trade-off. Hey, let's lock everything down. You're going to be super stable, make no change, which doesn't ever happen. Or let's lock everything down. You're very, very secure, but then you compromise speed, right? But as shown in these examples, speed does not have to come at the cost of stability. Stability does not have to come at the cost of security. Security does not have to come at the cost of spending a lot more money. And it's important as you become more software capable that you're able to get all of these values and not just one or the other. There should be no trade-off. And another great example at an awesome level of scale, 7,000 plus applications built in a cloud-native fashion. Again, very, very impressive. Yahoo Japan, again, one of our favorite businesses that we look to as a proof point of, and how we mentioned this bell curve, right? A lot of companies right at the edge, bleeding edge, that have done a lot of adoption. They've done sort of the heavy lifting for us as an industry by taking this journey early on and busting through the barriers and establishing templates that hopefully all of us can learn from. And that's what we're going to try and do a little bit here is understand what did T-Mobile do, what did DBS do, what did Yahoo Japan do that all of us could learn from. And in this position of privilege that Pivotal is in from watching these largest, most complex businesses transform, we have this awesome amount of knowledge that we can synthesize as insights to be able to offer back and say, hey, anybody else interested in getting to results of these kind, here's a playbook. Here's what we've seen work. Here is the extraction of the best from the 300 plus largest customers we've seen do this and offer that as a playbook to you. So, the first thing that is common to all of these large businesses is they're all trying to change how things have always happened. Now, this would be, what you see on the slide now would be very, very familiar to everybody who's been in the industry for a while. This is how things have always been done, right? This is the past. This is what we're trying to break out of. Not to say that this will disappear overnight and we will not have to deal this, tomorrow. We will continue to have a balance of some part of what we do stays like this, but we have to push to get some of our ways of working to move out of this, right? So you've got to change how you've always done it. You've got to fight status quo, right? You have to take on more risk. You've always outsourced all your technology skills and then not been interested in IT as a differentiator, but IT as a cost center. And then to make this change, new technology is necessary, right? I mean, cloud has done fantastic things for us. It's given us, a lot of scale options. It's given us lower cost. It's allowed us to do integrations faster. It's more secure by definition. And these days, it is so easy to go out and procure a new technology, right? Swipe a credit card if you like, or enable an integration in your platform if you like. My favorite thing that I speak to large businesses about is it's so easy to procure a container platform these days, right? But what you do with it is often the differentiator, excuse me, is often the differentiator and not just that you have a container platform, right? If you and 10 of your competitors could go out and have a cloud-native platform, a container platform, all at the same speed, you can all stand it up tomorrow for the sake of an argument by going out and provisioning in the cloud of your choice. But what you do next is what sets you apart, right, in the ability to reach those results. So new technology is necessary, but often it is not the only thing that will get you these results. So DBS, Yahoo Japan, T-Mobile did not get these results just because they purchased a piece of software. Yes, they had to purchase a piece of software. That's the starting point. But that by itself is not enough, right? And so just doing the same things that you've always done, but taking them from premise and putting into a cloud of your choice, whether it's online or public or private or hybrid, it's not going to go a whole long way in changing, the value you're getting from IT. You also have to change how you've always worked, right? You always have to change and challenge status quo to say, yes, now I have more technology at my disposal. Let's adopt different styles of working, different architectural patterns, different teaming structures, different languages, different interfaces, different programs, different ways of getting programs off the ground and delivering these programs, because that combination of new technology and new style of working is often the most powerful combination. Not one, not the other. Change your style of working and don't give your teams new software to work with, won't help. Give them a lot of new software, but no guidance on what to change, it's not going to help either. And then, moving on, I mean, this is a plug for how we help customers and large organizations make these changes in how they work. Pivotal Labs, I think most of you have heard of that brand. It's our brand for all things that we do in services to help businesses change and achieve the kind of results you just saw up there. And you should read this slide as 4 different things that you have to change in how you work in support of the new technology you've acquired. The first thing that you have to change is how you build products. Changing the way products have always been traditionally built to deploy a more customer-centric product development cycle is the first change. Having an intentful, purposeful program to modernize your legacy, your heritage applications is the second thing that you have to embark on. Changing the way your cloud platforms have always operated, moving away from a ticket-based multi-weeks to provision, many weeks to patch and upgrade culture has to change, and that style of operation has to change. And lastly, there needs to be this constant education and skill set building that needs to happen in-house with your partners, with your outsourcers, whatever be your decision for you. But there needs to be this constant skill upgrade all the time, something that Howie alluded to as well, because technology is changing so fast. We almost have this a double-edged sword of there are new patterns, there are new styles, there are new languages, there are new frameworks, and it's often hard to keep up. So paying attention to that is the fourth most important thing. And so to bring it all together, our prescription, having watched these large enterprises, here are 4 things you must have. You must have a cloud-native platform. You must have a place where your applications can run. You must have a place where you can reliably run applications that can auto-scale, that can self-heal, that are secure by default, and you don't have to throw 200 people at running the platform, but you can run very high productivity levels with your operations team. You need a lot of new cloud-native tools. You need caching services, messaging queues, you need more cloud-native database technologies, et cetera. That's the second thing that you need. You need to change the methodology of working, right? The product-oriented culture that I touched upon, having methodologies to modernize your existing legacy rather than being scared of it and leaving it alone. You got to be brave and take that on with the right methodology. And lastly, building a culture of a software-centric culture, right? Sort of a summary of our prescription. Now, one important component that I'll invite the next set of speakers, my colleagues here, to touch upon is this is a generic prescription, right? Now, you double-click a little bit and you talk about, well, what are these methodologies and what are these architectural patterns that we are seeing surface that you could take back as advice and start implementing in all new products you're building and platforms you're building, right? So to double-click and go deeper, I would like to now invite Shaun, our field CIO, and Jerome, our field CISO, to talk deeper into cloud-native architecture patterns and security patterns. So give them a big hand. And Shaun? Which one? Yep.
Thanks, Sachin. And thanks to so many folks in Singapore for taking the time and spending it with us today. We do want to jump in and look at 4 principles of cloud-native security. Really quickly, we'll introduce ourselves. I'm Shaun Norris. I'm the field CIO for Pivotal, covering Asia Pacific, Japan. And I spend most of my time out with customers across the region, helping them on this journey, modernizing, transforming to cloud-native applications and platforms. Jerome?
Good morning. I'm Jerome Walter. I'm the field CISO in Pivotal, which is similar to what Shaun does, but security focused. So I help customers embrace the changes that cloud native brings and adapt new methodologies for doing security from within.
So if I could ask the AV folks if you're able to bring our notes up, that would be fantastic as well. If you're not, then this is going to be a really interesting presentation. We have done it before, so we should be fine.
Who knows this? 1, 2. Wow, particularly few. This is Space Invaders, a game that is now, 30, 40 years ago, 40 years old. And if you think back 20, 30 years ago, the problem that we were trying to solve with computers was much simpler than what we had. So computing was starting, we were just trying to do simple tasks, and then we improved the computing, we improved what we were doing. And now, no company is going through an IT program without talking about the AI, machine learning, all the cloud native. And that's really the changes we have today. But these changes bring to the next slide.
So,
they bring in more complexity.
If we think of the kind of Space Invaders analogy of things, even video games were really simple 20, 30 years ago, and now today it looks more like this. This is a storm on Jupiter and just masses of complexity everywhere, and that's what we often see in our enterprise technology these days. Things are much more complicated than they were before, much more complex, and we need new ways of dealing with this. We need to look at new approaches, new tools, and things like, I've spent a fair bit of time in the banking industry, and it used to be that everything was down to batch processing. Now, customers expect real-time notifications of transactions. They expect real-time balance updates. They don't want to wait 24 hours to see that I spent some money on my credit card. We're in the Apple Pay world where I tap and immediately I get a notification on my phone saying you spent some money, and that's the expectation that's coming everywhere. So that's just one example of how consumer expectations are really driving us to think of things in new ways.
So if you're here, you're probably familiar with cloud native, right? And you understand that the world and the complexity we're trying to address requires cloud native applications. Earlier, IMDA was showing, right, the transformation happening in software. So we do require to do running cloud native application. You also need to have a cloud native infrastructure. If you're trying microservices on the plain old manually configured computers, good luck with that. But I'd like to take this opportunity to look back into the principle of cloud native and look at how they can change security and how they can improve security to solve some of the challenges we've been struggling with for the last 20 to 30 years with traditional methods of security.
So, we want to expand on an idea that our colleague Cornelia Davis, a VP of technology for Pivotal back in San Francisco, she and a colleague kind of launched these 4 principles of cloud native back at our Spring One conference a few weeks ago in Austin, Texas. And we thought it'd be great to share them again here, but also take our unique spin of, well, how would these 4 principles apply to things like security? Something that Jerome has spent a lot of time analyzing and researching and working in. And then, why are principles important in the first place? Now, I spent some time working for a small bookstore in the Northwest US that you might have heard of called Amazon. And while I was working there, I was lucky enough to go to an all-hands with Jeff Bezos, where he talked about why principles and tenets are really important. The whole Amazon bookstore then became the everything store really started out with just 3 concepts, as he explained it. He said, I can't imagine going into the future 10 or 20 years and someone saying, Jeff, I love Amazon, but I wish you charged a little more for everything. So, low prices are important. And I love shopping on Amazon, but I wish you had a little bit less selection. So vast selection of everything was important. And it's so great when I have to wait 3 or 4 weeks for you to deliver something. Please take longer to deliver. He says that's never going to happen either. So those 3 ideas, he said, we don't think they're ever going to change. And since we've identified those, we can invest and go all in on them. Now, if we take that concept of principles being really important and apply it to cloud native, we think these 4 principles, they might not be the only 4 principles, but they're certainly 4 key areas that we want to dive in and look at each one as they relate to building cloud native applications, cloud native infrastructure, and securing both. So Jerome, take us away into immutability.
I think if we look at the principle of what a cloud native application is despite the distributed and all that, is you cannot do it unless you have immutable infrastructure and immutable processes. And the immutable principle is quite simple. Once you ship it, you don't change it. You don't touch it anymore. That requires a level of automation that to be able to deliver a workload code in production without going manually configuring the servers. And that's one of the key aspects delivered by this immutability is repeatability. You don't want, if you're trying to run, like some of our customers, 100,000 containers, you don't want to have to do it manually every time. If your application has 200 endpoints and you need to be able to replicate, to distribute your application across several nodes, that gives you the reliability that we see in the largest companies. And if you take a little bit of a deep dive into how we deliver this immutability, if you're familiar with Pivotal Application Services that is built on Cloud Foundry, you know that when you push your code, everything is provisioned from the VM, from the build packs, and then you only push your code, and everything else is automated, so you don't have to go and manually configure everything. And if you think towards where we're going with Kubernetes, is the same challenges of, okay, you bring the underlying infrastructure, but how do you manage the runtime? And this is why we developed this open source project called KPAC. And in beta today is Pivotal Build Services that will bring the same level of immutability, not only at the VM level or at the container level, but the runtime itself. Automating the build of any workloads, you push your code, automating everything so that you can repeat and have the same outcome for the same code.
So we also see this pattern of immutability coming to things like data management. One of the big trends we see among our customers, and this idea of going from batch-driven to real-time, is in how you handle data and representing the events of your business as events in your code and your infrastructure as well. And so in the old days, we would have taken a relational database. We would have, take a shopping cart application. We would have said, Shaun added one thing to his shopping cart. So in that row, it would be update row where ID equals Shaun and set number of items in cart equals to 1, some sort of pseudo SQL statement like that. And then if I added another item in, we would have gone in and done an update statement on that same row and said, change the 1 to a 2. But anything caching it down line, updates are really expensive. And anytime you update something in place, you're kind of breaking this immutability principle. So what we're watching now is using things like Apache Kafka and then working with things like Spring and all the stream processing libraries in Spring. You can store a series of immutable events in something like an Apache Kafka topic, and then you can build a view of how many things are in your shopping cart by enumerating the events. And this is leading to much more scalable patterns. And by having the principle that once I store an event, I'm never allowed to change it. I can always add new events, but I don't go back and modify the existing ones. It also makes auditors and security people quite happy as well.
If you think about it, in security, we always want to make sure that what's running is actually what's supposed to be running. There is no extra malware, or you need to audit to make sure nothing has been modified in the back. And if you have a repeatable process, and if your infrastructure is immutable to the point where no one ever connects to it, what it gives you the predictability of the outcome, but also an auditability. You know what's running in your environment because no one ever goes to change it. And helps you also detect if suddenly one of your containers has weird or suspicious behaviors. The fact of distributing your application gives you fault tolerance. That's why we can handle hundreds of thousands of containers, you can have the scalability, and that's why Alibaba handles billions of dollars of revenue in one day, because it can scale up and scale down. But that also simplifies the changes. That also makes you able to patch at any point of time without an impact to your application. So those big challenges we had for the last 20 to 30 years in security of saying, hey, we have vulnerability, can go, please patch it, are becoming easier. And another very core aspect of cloud native security that is enabled by the distribution and by immutability is that now workloads are ephemeral. We used to be happy and run a competition on the best uptime, right? But if you want to keep your server up and running without patching it, that's not a very good idea anymore. If your application and your infrastructure is designed to be destroyed regularly, that means you ensure that what's running in your environment is what you expect, but also you reduce the attack window for an attacker to go and move laterally and infect your network. And that's really the core, because if you look at what in security we used to do, regardless of the APT and all those fancy terms, 98% of breaches have to do with those 9 core issues. And then if you take a second to look back into what happened to those core source of breaches, if your infrastructure and your credentials are ephemeral and are changed regularly, again, your attacker, by the time he's trying to get in, you've already changed the infrastructure, you've already changed the credential. Same for backdoor, same for malware. If you destroy continuously and repave continuously your infrastructure, you reduce your risk of running malicious workloads. That also means all the people who are doing scans and manual patching can now start working on the actual, really, value of security.
So let's talk a little bit about reactive. We already heard Josh Long this morning talking about reactive spring. I really enjoyed that, and I love every time I've heard Josh. And he's got to be one of the top 1% of live coders. So I think we were all really lucky to hear that from him. We want to look at it. I think he's done a great job of covering kind of how reactive really works well, and we don't want to add a whole lot to that. We want to talk about maybe how it applies to infrastructure. These platforms that we're going to build that are going to be more reactive. And then, we're going to talk about maybe the controversial idea of how reactive applies to security, because historically, reactive has been kind of a dirty word in security. Anybody know what this is? So these are drones. Yeah, I think I heard someone in the audience. And you might have seen at the last Olympic opening ceremonies, there was like a drone display. So, think of it if you were a programmer and you were going to program a drone display for an Olympic ceremonies. The way we might have tackled this a few years ago is, well, we'll have precise 3D coordinates for all the drones, and we'll make them sit in those coordinates, and then they're all going to move at the right time, and we'll feed them data. The trouble is, if you start to think about doing this in the real world, well, there might be wind currents. Those wind currents might be different from one side of the drone field to the other. And so there's really no way that you could hard code or anticipate, kind of centrally control all the movements of the drones up front. You really need each one to be reactive and autonomous. So this idea of reactive or autonomous code, I think, is quite analogous to what Josh was talking about earlier about code that gets the job done, but much more efficiently. When we look at continuous delivery as well, you want your builds, and we work with a lot of customers going through this journey of what's the supply chain look like to get your ideas or your applications for your customers all the way from an idea, your business says we'd like to do this thing, to getting into production. I did a talk a couple weeks ago with a gentleman, Dapeng Liu from DBS, and we did a talk where we talked about how they've gone from deploying once per month to 4 or 5 times per day, and how much better the business cooperation and value is. And not only that, but how much more enjoyable it is a team to work in, and how high the employee engagement has gone in that team. So the technology enables it, but it actually makes it a lot better place for all of us to work as well. Let's though, because this is a really interesting area, let's talk about reactive and security.
Oh, tell a security guy that is reactive, you'll probably get a punch in the face. So reactive is fairly, a bad word in security because that means you're always too late. But if we think about how today the businesses are doing, and what you've heard this morning is really, there is a high competition. We need to be better at software, not for the sake of doing software, but for winning the competition, the business competition. And I like to look at security and the future of security through the analogy of Formula One. Because it used to be that when you you do a race, you just build the car and let the driver go, and whatever happens, too bad. But nowadays, you win the race, the cars are continuously sending back telemetry. The engineers are on the deck configuring and adapting the configuration of the car to adapt to things. They are aiming to predict if there will be a failure, if they need to change a tire or something, instead of waiting for something to break down. And it's really the same change we see in security. If you are trying to do a one-size-fits-all security that applies to things, then you're removing the autonomy of the developers who are trying to innovate, right? And that's really a shift that is happening. You can move to the other place. To really move from the all the security tools that you buy and you put them at a perimeter and everyone has adhered to it, to something that is much more focused towards outcomes, who is much more adaptable to every single project and every single technology stack, that leverage continuous feedback instead of policies that you assess once in a year, and is really moving the responsibility of security not from a security team anymore, but distributed to the team who actually delivers the value of the business, to the developers who run the operation, to make them more enabled from a security standpoint as well. So we've seen immutability, we've seen the reactive programming, and Josh this morning did a good job. But once you move out of the imperative programming, there is a challenge. And the challenge is, in what state is your system? You're moving towards don't do self-configure anymore, self-configure and self-adapt. So that means today there is a new challenge: is how do you reconcile all of those pieces to know exactly and to make sure you deliver your content? And then we move back. That moves back to what we saw earlier, right? If you have the repeatability of your processes, if you have the repeatability of your infrastructure, then you reduce your risk of, the snowflake configuration of this out-of-bounds software that you don't really know in which condition it is. You really improve your ability to know the state and to manage the changes that matters. The changes that matters are the ones who deliver value and not the changes of your infrastructure. And that's really, sorry, you want to cover this one?
Yeah, this is one of the challenges of pair presenting. Anybody who's worked with Pivotal Labs knows we really believe in pair programming, where we actually have two people working on two keyboards, two mice, and one screen and one computer, and you pair back and forth. So we've been experimenting in our team with pair presenting, and we're still working through the kinks, but we're getting there. Believe me, it's more than twice as difficult as single-threaded presenting. This idea of reconciliation is really interesting. I've been in the kind of operations and infrastructure game for the best part of 25 years, and I can say 25 years ago, we also did reconciliation, but it was all manual. It was through remedy tickets and ITIL, and lots of different siloed teams, and lots of late-night phone calls, and even some yelling occasionally. But the big worry was, what is the state of our running systems in production, and could we get them back to that way if someone wiped them out? One of the large organizations I work with, they had a major risk in their risk register, which was how would we survive a wiper attack? Which was if some worm propagated itself through our data centers and wiped out everything, how would we get it back? Might be an interesting question for you to ponder during the break as well. How would you get your production environment back? Well, one of the reasons why Kubernetes is so exciting, and I think it is one of the biggest things to happen in my career in infrastructure, is because it automates this idea of reconciliation. So if we start at the bottom of what admittedly is a pretty busy slide, and you look at the pod being the kind of fundamental core building block of Kubernetes. So I deploy containers into pods, and those pods get built up into replica sets, and the replica sets are wrapped up in a deployment, and then I use service objects to kind of wire in the deployments to the outside world so that users can actually reach them. Each of these have an automated reconciliation loop where it's going in and saying, this is the state that I expect. Now let's go check. So for example, if I say in my replica set I need 4 copies of an Nginx web server running, the reconciler in Kubernetes is constantly going through this control loop cycle saying, do I have 4 running? Yes, I have 4 running. I have 4 running? Yes, 4 running. Oh, I only see 3 running. 1 must have crashed. I need to fire another one up, and it'll just launch another one. And this used to all be done manually, often quite badly by self-admission. And this is a huge step forward to be able to have this automated reconciliation as a core part of cloud-native infrastructure. Let's talk a little bit about streams and tables as well, because reconciliation, we're seeing really large customers around the world start to use this idea of event processing as a way of reconciling what's actually in their inventory. So we already talked about, could I take an inventory of everything in my data center and know exactly and get back to that state? Well, what if you're selling groceries and you want to know exactly how many loaves of bread you have in thousands of grocery stores? One of the techniques to do that is to use things like an event log, or we see that often implemented with Kafka, and use that as a source of truth for what's happening in your environment. Another example of this. And what you'll end up seeing is, rather than have one giant relational database, is you might have a delivery system and a return system and a shipment system and maybe a store of damages system. And these are all updating logs, which then get reconciled back to some sort of inventory system. And this is a really powerful pattern. If you're grappling with some of these issues, come see us afterwards and we can share some success cases of other customers we've seen who've had really good success with this. Back to Jerome, because I think another really interesting reconciliation idea is this one of chaos engineering.
Since we shared a lot this morning, but if you understand that today we're proving new technologies that helps you do your job better and scale better, but at the end of the day, it's still a very complex system. When you move towards an infrastructure that has hundreds of thousands of containers or have thousands of applications running intertwined and changing regularly, knowing that you're going to deliver the outcome of your application, regardless of what's going to happen, is a key challenge, right? And if you think about it, our systems have always been a black box. We write pages and pages of documentation of what we think they are, but actually they've almost always are very differently. I've done years of BCP and DR, and I can guarantee you it never happens according to the plan. So you have 2 solutions. Either you design and you hope that nothing's going to break, and you hope that the MAS will be happy with your 4 hours of downtime when it happens, or you work towards being better and guaranteeing that you know that the outcome will be better, will be good, regardless of what's coming in and what are the outcomes. You want to make sure that your system is resilient and is able to self-heal, to reconfigure. One of the biggest advocates and one of the first to start was Netflix, and they started because the underlying infrastructure was awfully unreliable. You don't want to say, oh, the server was down, so my application was down. It's not my problem. What you want is an application that reconfigures, that can handle when things are broken, that can handle when the input is not what you were expecting. And so this is where chaos engineering becomes extremely important in the management of cloud-native architecture. If you're not actively injecting failures on your system to make sure that they still behave how you expect them to be, then you're praying that things are not going to break. And so you really need to consciously inject failures and learn from what is the output and what is the behavior of your system so that you can continuously improve and fix and being ready for the big outage.
So, just back to one final point from me on this, on chaos engineering. Essentially, I've had to relearn everything I learned in my career about infrastructure and how to deliver highly available systems. It used to be we did it all with hardware and double or triple everything and data centers, and now software and tools like chaos engineering have meant that we can deliver many, many nines to the end user with fewer nines underneath in the infrastructure, which is a really remarkable difference. And once you realize that, you can actually go faster and you can get a lot more done, but it does require this kind of open-mindedness. The last one we want to cover is this idea of composability.
Today, when you write a software, you're not gonna go and write every single line of code and write your Tomcat and write all your components, right? If you want to focus on value and on adapting and on being able to deliver and spend your time on what delivers value to your business, you need to be able to compose with different components and different parts of your systems. And that's really where it's important to understand that we talk a lot about Kubernetes in the world of cloud-native infrastructure, but very often people think cloud-native Kubernetes is just an orchestrator of containers. Kubernetes is just an orchestrator of resources, and the resources in your hands. That's really where you can go and say, hey, for this application, I need those components to be all together, and Kubernetes will make sure and will go and build those resources and guarantees the state, guarantees the reconciliation. So that's really where it's important to understand that you can do more than just containers with Kubernetes, and it's only a beginning of what's happening today. That's why we're so excited to get to deliver this.
And we're seeing this as well with event streaming again. Back to this idea of treating your business as a series of events. What setting up microservices and using events allows you to do is if you have a new business idea or a new experiment you want to run, in the past it might have been prohibitively expensive to go and recode into your core systems and introduce a new flow or a different way of doing a business function. Now with microservices and events, you can have new microservices start consuming a Kafka topic, for example, or some other sort of event log, and start doing that almost in independence of all your existing business systems. So we're watching people be able to be much more agile, much more nimble in terms of testing new experiments, testing new ideas by applying some of these different ways of thinking. So when you hear composability, I kind of think of it as extensibility as well. Let's kind of wrap up here. We've got a couple minutes left. We've talked about kind of 4 cloud-native principles. Hopefully they kind of resonate. We've done a very high-level flyby, so if you want to have further discussions, we have a large team of Pivotal folks here at the event, and we're easy to find online as well. We hope, though, that you kind of take these back and start to use them as a litmus test. If you've got your own infrastructure platform engineering effort going on, see if it passes these four tests. Or if you're building new cloud-native applications, does your application architecture kind of reflect well when you use this lens to look through? And then your security. As you start to handle security, does it reflect well there as well?
So, the core 4 principles are extremely important, but let's remember and not forget, these principles are simple, but the reality is still very complex. And what we need to solve today as a business are very complex, and as a result, we build complex systems. And this is where it's important, and we, as Pivotal, aim towards making it simpler so that you can focus on the business complexity rather than the infrastructure and the underlying complexity.
I think we promised you a little bit about roadmap. You're going to see this VMware Tanzu and a coming together of Pivotal, particularly in the build section of this. And so, look forward to a lot more news and exciting stuff to come on that. If we kind of double click into that, you're going to see a lot of the Pivotal experiences that you've really come to enjoy, like CF Push and, kind of fire and forget running in production. Back to Josh saying production is the best place in the world. Well, we all think so too. We're really excited that this is going to be part of this Tanzu vision at VMware, where a lot of these developer experiences are now going to be available with Kubernetes at the center and at the core. That's I think, if you take one thing away today, kind of product roadmap-wise, is all of your existing Cloud Foundry, Pivotal platform experiences are going to work, but you're going to see them evolve to have Kubernetes at the core over the next few weeks and months. So I think on that, we want to wrap up, and I just want to thank Jerome. It's been fun to go through this with him and with all of you. And let's go off script for 1 second. there's a ton of work that goes on behind the scenes to make an event like this. And so Seiwei and the marketing team have done like weeks and weeks and months of work to put this series together. So let's give them a quick round of applause. And she's going to be very upset with me for sharing this, but Seiwei very recently, earlier this month, completed her 6th major world marathon. Anybody else in the room done 6 marathons? Yeah, I figured that would be a very small group. So let's give her a round of applause. That's an amazing achievement, and we worked with some fantastic, remarkable people.